The first objective will be covered in 3 parts. At the end of this Part 3 video, you should be able to fully compare the characteristics of the inner planets and summarize the features that allow Earth to sustain life.
Earth. The third planet from the Sun is Earth. The orbital period of Earth is 365 and 1/4 days, and Earth completes one rotation on its axis every day. Earth has one large moon. Earth has had an extremely active geologic history. Geologic records indicate that over the last 250 million years, Earth's continents separated from a single landmass and drifted to their present locations. Weathering and erosion have changed and continue to change the surface of Earth. Water on Earth. Earth's unique atmosphere and distance from the Sun allow water to exist in a liquid state. Mercury and Venus are too close to the Sun, and any liquid water on those planets would boil. Mars and the outer planets are so far away from the Sun that the water freezes. Earth is the only planet known to have oceans of liquid water, as is shown here. However, scientists think that Jupiter's moon, Europa, may have an ocean under its icy crust. Life on Earth. Scientists theorize that as oceans formed on Earth, liquid water dissolved carbon dioxide from the atmosphere. Because of this process, carbon dioxide did not build up in the atmosphere and solar heat was able to escape. Thus, Earth maintained the moderate temperatures needed to support life. Plants and cyanobacteria contributed free oxygen to the atmosphere. Earth is the only known planet that has the proper combination of water, temperature, and oxygen to support life. Mars. Mars, shown here, is the 4th planet from the Sun. At an average distance of about 228 million kilometers from the Sun, Mars is about 50% farther from the Sun than Earth is. Its orbital period is 687 days, and it rotates on its axis every 24 hours and 37 minutes. Because its axis tilts at nearly the same angle that Earth's does, Mars's seasons are much like Earth's seasons. Mars has been geologically active in its past, which is shown in part by the presence of massive volcanoes. A system of deep canyons also covers part of the surface. The Valles Marineris is a series of canyons that is as long as the United States is wide, about 4,500 kilometers. The canyon is thought to be a crack that formed in the crust as the planet cooled. It was later eroded by water.
Martian volcanoes. Tharsis Montes is one of several volcanic regions on Mars. Volcanoes in this region are 100 times as large as Earth's largest volcano. The largest volcano on Mars is Olympus Mons, which is nearly 24 kilometers tall. It is 3 times as tall as Mount Everest. At 550 kilometers across, the base of Olympus Mons is about the size of Nebraska. Scientists think that the volcano has grown so large because Mars has no moving tectonic plates. So, Olympus Mons may have had a magma source for millions of years. Whether Martian volcanoes are still active is a question scientists have yet to answer. A Viking landing craft detected 2 geological events that produced seismic waves. These events, called Marsquakes, have indicated that volcanoes on Mars may be still active. Water on Mars. The pressure and temperature of Mars' atmosphere is too low for water to exist as a liquid on Mars' surface. However, several NASA spacecraft, such as the Mars rovers Spirit and Opportunity, which landed on Mars in 2004, have found evidence that liquid water did exist on Mars' surface in the past. Mars has many features that are characteristic of erosion by water, such as the branching paths that look like gullies, as is shown on the screen here. Scientists think that other features on Mars might be evidence of vast floodplains produced by a volume of water equal to that of all 5 of Earth's Great Lakes. The surface temperature on Mars ranges from 20 degrees Celsius near the equator during the summer to as low as negative 130 degrees Celsius near the poles during the winter. Although most of the water on Mars is trapped in polar ice caps, data from the Mars Global Surveyor suggests that water may also exist as permanent frost or as a liquid just below the surface. If liquid water does exist below Mars' surface, the odds of life existing on Mars will dramatically increase. However, no solid evidence of life on Mars has been found. At this point, you should be able to fully compare the characteristics of the inner planets and summarize the features that allow Earth to sustain life.